Okay, let's take a look at another problem here, only this time we've got a radical inside of a radical. We've got a fourth root inside of a square root. Now what we can do with this, again, is to remember that this product, which is in here, is being raised to a rational exponent, or a fractional exponent. So we can, if we keep that, if we keep the product written inside parentheses, we're grouping that inside one grouping symbol, this radical, that's a fourth root, so I can write it as a 1/4 power. Now that power itself, so really what I've taken care of at this point is everything here. I'm taking the square root of all of this. So if I enclose this with some brackets, I'm taking that square root, which means I'm taking that to the half power. So what I've got is sort of this, this Russian nesting doll, if you will, of an expression raised to a power, raised to a power. So once we work inside out to write that, we can look at this as powers of powers of powers. So it's one big product of these powers that we can multiply through. These exponents come through here. If we take that piece by piece, we can take 1/2 times 1/4, which is 1/8. So we've got 3x squared y cubed now raised to the 1/8 power. And we can then, because we have an exponent outside these parentheses like we did before, with a product on the inside, and that's key, I mentioned this before. You cannot distribute exponents into sums and differences. You can distribute exponents into products, and we've got 3 terms that are a part of this product in here. We're going to have to distribute that 1/8 into all of those values. So I can distribute the 1/8 to the 3, to the 2, and the 3 here as well. What we end up with is 3 to the 8th power, x to the 2 times 1/8, which, do your margin work, you get 1/4, and then y cubed to the 1/8 power. I'm multiplying these exponents as well. We get y to the 3/8. Written with those rational exponents, that's our simplified form.